Can we use the area model for multiplication to factor polynomials? Yes, we can. The process works like this. Take a trinomial like 2x squared plus 11x plus 15. The first two steps are always the same and always the simplest. Whatever this initial quadratic term is, that is the term with the x squared, always comes from that upper left-hand corner. And whatever this constant term is, always comes from the lower right-hand corner. This is because if we have a factorable second-degree trinomial, it must have come from the product of two binomials. Using the area model, or what I'll just call the box method, we would have laid it out like this. X plus 3 across the top of our box, x plus 8 down the side of our box, and then we would have multiplied all of these terms together as if we were finding the area of a bunch of rectangles. The only trick is figuring out what fills in these other two boxes. Fortunately, we can see there is a connection between the sum of those two boxes, which ends up being the linear term of our trinomial, and the product we were getting from multiplying those numbers. In this case, again, we want the two middle boxes to add up to 11x, but the trick is we need them to multiply up not to 15, but instead to the product 2 times 15, whatever the coefficient of your quadratic term is times the constant term itself. I usually have students set up a little table. We need the product of two numbers to be 30, but we need the sum to be 11. From here we can just list out the factors of 30, or perhaps we recognize right away, yeah, it's 5 and 6 that multiply up to 30 and add up to 11. So we're going to use the 5 and the 6 to fill in our other two boxes. The process now is just about looking for common factors on our rows and columns. For example, 2x squared and 6x have a 2x in common. So that's what must have gone above that particular column. 2x times what makes 2x squared? X. So that must be what we were multiplying by. For that matter, x times what makes 5x? 5. So that must be what we were multiplying by on that right-hand column. 2x times what makes 6x? 3. And then we can always check our work. Is it true that 5 times 3 makes 15? Yes. And so this trinomial factors as the quantity x plus 3 times the quantity 2x plus 5. One interesting thing to observe about this process is that the reason it works is the cross products within the box always have to be equal to each other. I've always wondered if there's a connection to matrices, because another way to say this is that if we set this up in a matrix, 2x squared, 6x, 5x, and 15, the determinant of this matrix would be equal to 0. But someone more knowledgeable about quadratics and matrices is going to have to tell me if that's a legitimate connection or just a fun coincidence. Either way, no weird slide and divide required. We can use the box method or the area model for multiplication to factor trinomials just as easily as we can use it to multiply out binomials in the first place.